Okay, here's our video on writing and solving two-step equations, part 1. So, we already went over two-step equations, how to solve them, but now we're going to solve them and write them. So again, let's review. Let's say you saw this equation, 2x plus 3 equals 12. So how would you solve this? Let's just review. Okay, again, remember you want to solve any addition or subtraction first, because again, you want the x, the variable, alone on the two sides of the equation. So again, we'll minus 3, right? That cancels out. And now you bring down a 2x. Right, we have 2x equals 9. And again, we want to divide the 2 because we want the x by itself. And x equals 9 over 2, or you can simplify that by saying 4 and a half, or 4.5. So that's how we solve that. But how would we write an equation like that? What if we saw something like 2x plus 3 equals 12? How could we explain that in words? Well, here's an example. Here we're saying Liam charges $2 an hour plus a one-time fee of $3. Right? So the x in this case is going to represent hour. 2 times an hour, $2 an hour that is, plus the initial fee or the one-time fee of $3 will give us 12. So without the 12, if we hide the 12 for a minute, we're saying here that Liam, whatever he's charging you for, let's say it's babysitting or something, he's saying he's charging you $2 an hour. You can also write this as 2h. We can use the h for hour. And he's charging a one-time fee of $3, right? So you have to pay him $3 no matter what. But and then $2 every hour. And the 12 just represents what the final cost was. So when we're doing one-step equations or any equations, we're trying to find a relationship between the cost and hours for this problem. The cost in this case would be the y. Generally it's used as y. And the hours were the x for the previous equation. Let's look at it again. Again, the h was the x and the y was the cost. So again, with all equations we're doing, we're trying to find a relationship between the x and the y. Again, this is what the equation looked like. 2h plus 3 equals c. And again, you can also say 2x plus 3 equals y. And if you remember, it could also be the other way around. So let's see if you can do this one. Ted's taxi charges $1.50 per mile and an initial fee of $5. How would you set up an equation like that? Okay, he's charging $1.50 per mile plus $5. That's the initial fee. You step into the taxi, you enter the taxi, and you're going to pay $5. Even if you go less than a mile, you're still going to pay $5. And then $1.50 every mile, and you'll get the cost, C. And again, you could write it like this also. You can flip it around. And normally the cost, or the C, is a y. And the miles you can also put as x. And here's our two-step equation. Now the x, this x, or the m, is called the independent variable. And the y is called the dependent variable, but I'll go over that in a minute. Now a lot of times we can use one-step equations when we're dealing with temperature conversion. As you know, in the United States we use Fahrenheit. But in most countries around the world they use Celsius. So how can we convert Celsius to Fahrenheit? And there's a formula I'm going to show you. Right? So if I wanted to convert Fahrenheit to Celsius, here's a formula. It's 1.8 C plus 32 is going to equal what the Fahrenheit is. So it's whatever the Celsius is, I'm going to times it by 1.8, then add 32, and I'll get the Fahrenheit. Sometimes you can see it like this. Instead of 1.8, you can see 9 over 5 C plus 32 equals F. So that's how we convert. So for example, let's say I said that the Celsius, let's say you're in Rome or somewhere in Europe, and the Celsius says it was 20 degrees. How would you find out the Fahrenheit? So again, the Celsius is 20. Use the formula and try to find the Fahrenheit. So pause the tape now and see if you can answer that. And again, you can use this one or that one. They're both the same. Okay, so again, I said the Celsius was 20, so we have to plug in. That means instead of it being C now, it's 20. Right, so let's put this in. Instead of saying C, we're saying 1.8 times 20 plus 32 will give us our Fahrenheit. And 1.8 times 20 is 36. We add 36 plus 32, and the Fahrenheit is 68 degrees. So if we were in Europe and it said 20 degrees Celsius outside, and in America we think 20 degrees is cold, but it's actually 68 degrees. Okay, so here's a term we need to know before we go any further. Function. A function is a relationship between two variables, and we did it already with the relationship between an x and a y. When we found the cost, or when we found the Fahrenheit, that was the y, right? And in order to find the y, we needed to find out what the x was, because the x was independent. So we're going to deal a lot with functions. Here's an example. We can have an x and y box, which you have seen before. And this x and y box, this is the independent variable, and the y is the dependent variable. In other words, the y is depending on what the x is. So in this case, we have what x is, and we have what y is. And we're trying to find a rule, a function rule, or a rule of if we have x, how can we get y? And sometimes you can look at it and you can find the rule. Right? We want to find a multiplication or division rule. Well, how can we get 5 if we have a 1? How can we get 10 if we have 2? The rule has to be the same for each of these numbers in this x and y box. It's also called a domain or range box. It's also called an input box, or an in box, and an out box. Say input, output. So the rule here is, what do you think the rule is? Multiply by 5, right? Multiply by 5. That's the rule. Let's see if it works. What's 1 times 5? 5. 2 times 5? 10. So what would be the missing numbers here? Now that you know the rule is multiply by 5, what are the missing numbers? Okay, well 3 times 5 is 15, so that's the missing number there. Now, let's look at the 45. What times 5 is 45? Right? 5x equals 45. We can do a little equation like this. We can divide it out. And x equals 9. Let's check. 9 times 5? 45. So again, this is an input-output box. Now sometimes you see it this way. Sometimes it's horizontal. It's the same principle. You're either going to see it horizontal or vertical. So this is horizontal, and this is vertical. And again, the rule is times 5, times the input, or times x by 5. Now if you know the rule, you can make an equation. The rule was multiply by 5. Multiply what by 5? X. Multiply by 5 gives you y. So that's the equation. We just made an equation by looking at an input-output box. Find the rule. It's very important. Find the rule first. 5x equals y, or you can say y equals 5x. Most of the time you see it with the y here, but it doesn't matter. It's the same thing. Find the rule. Okay, here's a word problem here. Funland charges $1.25 per ride and an entrance fee of $20. How can we make an equation based on that? What is the x and what is the y? Okay, well, let's look at it. It's $1.25 per ride. In this case, per ride is the x. It's $1.25 x, or you can put r. Whatever the rides are, you're going to times it by $1.25. And there's an entrance fee of $20 plus 20, and that's going to give us our cost. So here's the equation. So let's say you go to Funland and you go on one ride. Well, it'll be $1.25 plus 20. What if you went on 8 rides? What would be the final cost? Okay, so if you went on 8 rides, just plug in 8 with the x. So $1.25 times 8 is 10. So don't forget the initial fee. When you walked into the park, you had to pay 20. So your total cost would be $30. Of course, this doesn't account for any food you bought. Okay? So here's another question for you. How many rides can you go on for $160? Now, what do you have already? You have the cost. Remember, it's $1.25 per ride, R, or you can use X, plus the initial fee of $20, and your final cost has to be $160, not including food. This is just the basic equation here. So this is just an equation. How would you solve this? Again, it's a two-step equation. See if you can solve this. Okay, so again, let's look at this. So you have $1.25 per ride equals 140. Divide out the 1.25 on both sides because we want to get the r by itself. Divide out the 1.25. And you have r equals 112. You can go on 112 rides for $160. Okay, so let's look at another example here. Here is an input and output box, the main range box, but it's horizontal. So again, the independent variable is the top, it's the x, and the dependent is the y. Okay, so we want to know what rule we can use to get y. How can we divide or multiply x to get y? If you know the rule, you can make an equation. Okay, so what do you think the rule is? 12 divided by what is 4? Okay, well 12 divided by 3 is 4, right? Let's see if it works. What's 15 divided by 3? 5. So what's 30 divided by 3? So there's the missing number there, 10. Now over here, if we can divide this way, we can multiply going up. So 11 times 3 would give us 33, and we can now we know the rule is multiply or divide. And it's actually, you can do both. So it's actually divide by 3. Right, we're dividing by 3. And if you divide by 3, that means you're multiplying by 1/3. This is something to remember. If you were dividing by 5, then you would multiply by 1/5. You just do the inverse. So the rule is to divide by 3 to get y. So if you divide x by 3, x divided by 3 will give us y, and that's the equation. Now remember, this is the equation, but you can also do multiplication. Remember I said if you're using 3, if you're dividing by 3, you can also multiply by 1/3. 1/3 x equals y. And we talked about that before. So once you know the rule, if you know the rule, the multiplication or division rule, you can form the equation.